Evening. Hi, it's Amy Fuchsteiner back for elementary algebra. We have just one section left to do in chapter 7. This particular section goes over some ideas about rates, ratios, and proportions. We're going to use the proportions to solve some word problems, and then we're going to use the proportions to solve some triangles, some problems dealing with similar triangles. So let's take a look at some of the basic definitions to make sure that everybody's on the same page to start. The first is the idea of a ratio. A ratio is a comparison of two quantities of the same unit. Ratios are generally written in fraction form, and they're made up of two whole numbers of the form a over b, where both a and b are integers. A rate is the same idea. It is also a comparison of quantities, this time of different units. We use rates all of the time. So rates have a little bit more leeway, but they are generally also of the form a over b, although sometimes they will be what's known as a unit rate, where b is a value of 1. Okay? We're going to translate some of these into a ratio in simplest form. For example, here we are comparing 12 ounces to 27 ounces. In a ratio, the first number would be in the numerator. So this is 12 ounces in comparison to 27 ounces. Because the units are the same, they will effectively cancel out, just like if they were X's or Y's or some other letter. This leaves us with 12 over 27, which we would then reduce to lowest terms, 12 being 4 times 3, 27 being 9 times 3, and we would reduce this to 4 over 9. So 12 ounces to 27 ounces would reduce to the ratio of 4 to 9. This tells us that whatever there are 4 units of, we would compare that to 9 units. So for 4 wins, there are 9 losses. For every, let's say 4 cups of flour, you put in 9 cups of sugar. It's the same unit, 4 parts of one and 9 parts of another. Like if you've ever mixed any kind of chemical or any kind of recipe, this makes a little bit of sense to you. I have an example, but I don't know if I should share it. So we're gonna keep going here. All right, problem number 2 is 154 centimeters to 2 meters. I need these to be the same unit. So I'm going to convert the meters to centimeters. I know there are 100 centimeters in 1 meter. So I'm going to say this is 154 centimeters to 200 centimeters. I can't start canceling until these are the same unit. Since 2 meters is 200 centimeters, now I can look at this and start canceling. So I can cancel my centimeters. That gives me 154 over 200, which I can cancel again. 154 over 200, that's 77 over 100. Is that right? I just need to do 154, divide that by 2 to be sure. Yep, 77 over 100, and it won't reduce any further, so this is as much as I can do. Just reduce it to its lowest terms. Notice that, again, I did have to convert that first. Without converting that, the ratio will not work. All right. Now let's take a look at rates. Rates are comparisons of different units, as we said above. If I have 495 miles in 15 hours, 495 miles is the first number. It goes in the numerator. 15 hours goes in the denominator. I cannot cancel the miles and hours, but both the 495 and the 15 are divisible by 5. So if I take 495 and divide it by 5, I get this is the same as 99 miles in 3 hours. But 99 and 3 are both divisible by 3, or 33 miles in 1 hour. This has a 1 in the denominator. It is known as a unit rate. Has a special name. And that special name comes from the 1 being in the denominator. We would often write this as 33 miles per hour. The per hour making reference to the fact that that means 1 hour. And sometimes we write it as 33 mph. That's an American abbreviation, but it does mean miles per hour. Here we have $5,788 for 482 meals. I cannot cancel the dollars with the meals. They are different units, but I may want to look at reducing this. So 5788 divided by 2. So that's $2,894 over 241 meals. 2894, 241. Does 241 divide out? Let's see, because if 241 is prime, if that doesn't go any further, then I can't divide that out, and I just got to leave it this way. But if 241 breaks down, let's divide it. It's not going to be divisible by 2 or 4 or 6 or 8. No evens there. I don't think it's divisible by 3, because that's an anticept, so it's not going to be divisible by 3, which means I can knock out a 6 and a 9 and any other multiple of 3. So I'm going to jump to 7. Nope. 241 divided by 7. So that knocks out any multiple of 7. 8, 9, 10. I'm going to see. I don't think it's divisible by 11, but we'll try. Nope. Came close, though. So that knocks out any multiple of 11. Let's try 13. What is that? 241 divided by 13. Nope. So that knocks out any multiple of 13. I can't do 14. I can't do 15. I can't do 16. What about 17? Nope. 18. No, 2 didn't work, so 18 won't work. 19. Nope. 20, 21, 22. 23. I don't think 23 is going to work. That's too close. Okay. I think that's prime. So I think that's as much as we can do. So as we're looking at this, this is as far as we can do to reduce it. This is reduced as far as it will go. Now, if I want the unit cost, then I would take the $5,788 and I would literally divide it by 482 meals. I would do the actual division, not just reducing, but I would do the actual division. 5788 divided by 482. Oops. And I get 1201. Because this would give me the unit cost. Again, essentially saying that the unit cost is $12.01 per meal. Didn't work out evenly because I got all those decimal places. So it makes sense that I couldn't get that to go any further, but $12.01 per meal. This is an important piece of information. When you're working in a restaurant, you want to know what the average ticket cost is. That's the unit cost or the cost per person. It's always the cost divided by the people, averaged out. So yeah, but that's a slightly different thing than a rate. A rate can have two numbers in it, the $28.94, $2,894 for 241 meals. This is the reduced rate or the rate in reduced form. I better say that, rate in reduced form. But when I divide it out, that's known as the unit cost, and it's a slightly different thing. Okay. I think we got to talk about proportions now. Now, what is a proportion? A proportion is a comparison. Basically, when you set two ratios or rates equal, that's when you create a proportion. A proportion generally looks something like A over B is equal to C over D. When you do this, A over B is equal to C over D. I should say some people write it A is to B, just like C is to D. I'm not a huge fan of this writing. I much prefer it in the fraction form, but this allows you to see the two parts of a proportion. And the parts of a proportion are known as the extremes. Those are the ones on the outside. The A and D are known as the extremes. And then the ones in the middle, the B and C, are known as the means. So the means are the two in the middle, the extremes are the one on the ends. When you see this written out as equal fractions, B and C are the means, and A and D are the extremes. The fundamental property of proportions says that the product of the means must equal the product of the extremes. This is just a fancy way of saying cross multiply. That's all this is, cross multiplication. The product of the means must equal the product of the extremes. If that doesn't happen, then you don't have a valid proportion. You may think you have a proportion, but if the means, product of the means, does not equal the product of the extremes, you do not have a proportion. So cross multiply. Product of the means is equal to the product of the extremes. That's what makes it valid. So here we go. First example, we're going to determine if each statement creates a valid proportion or not. So we're going to look at the product of the means, 13 times 5, and we're going to see how that compares with the product of the extremes, 7 times 9. If they are equal, we have a valid proportion. If they are not equal, we do not have a valid proportion. So 13 times 5 is 65. 7 times 9 is 63. These are not equal, so this proportion is not valid. I may think I set it up correctly, but I did not get an equal cross product, so it is not. All right, let's look at number 6. The product of the means, that's 12 times 20, or 240. Does that equal the product of the extremes? 5 times 48, which is again 240. They are equal, so this is a valid proportion. We will use this to check later. Okay, so once I've set that up, I can now use this to solve my proportions. It must be true that the product of the means has to equal the product of the extremes. So it has to be true that 5 times a negative 1. Remember, there was a negative in front, and I almost always put it up top. I don't need it both places, so I'll switch that to a plus, and I'll move the negative up in the numerator. Has to equal the product of the extremes. So 5 times 3a plus 2. Now I just want to solve this as I normally would. Negative 5 is equal to 15a plus 10. I'm going to subtract 10 from both sides. And I have a negative 15 is 15a. I'm going to divide by 15. Negative 1 is equal to a. Yay! Likewise, for the second one, the product of the means, that's 5 times 3, has to equal the product of the extremes, x times x plus 14. This is going to give me 15 is x squared plus 14x. I'm going to move that 15 over. So we have 0 is x squared plus 14x minus 15. Now, this is an x squared. This is a trinomial. We should have some bells dinging. Is it factorable? Will this factor out? Are there two numbers that when multiplied, they give you a negative 15, and when added, they give you a positive 14? What two numbers multiply to give you a negative 15, but when added, you get a 14? So that's going to be a negative 1 and 15. Bam, right there. All right, so this factors into x minus 1, x plus 15. Together, they multiply to give me 0. So according to the zero factor property, x minus 1 is equal to 0, or x plus 15 is equal to 0. My x would be 1, or my x could be a negative 15. Based on these solutions, I will check them. If x is 1, then I have 1/5 would be equal to 3 over 1 plus 14 is 15. Cross multiply, I get a 15 and a 15. So the 1 checks and is a valid answer. If I check the negative 15, I have a negative 15 over 5 equal to 3 over negative 15 plus 14 is a negative 1. When I cross multiply, I get 15 is equal to 15. This also checks. So for my solution, x could be a 1 or a negative 15. Yes. Okay, great. Now, let's see. I think we got some word problems left. Yeah, we got to solve some word problems. We got to solve some triangles. Okay. We're going to use proportions to set up the problems. So most of the time, these are going to be rates. And if I can determine what I'm comparing, I can use that to help me set up the problems. All right, 6 tickets to the Van Gogh exhibit are $285.30. How many tickets will 808.35 purchase? Okay, so I'm comparing the number of tickets to the cost. All right. Once I know what that is, that's going to help me as I do this word problem. I can see from the word problem that 6 tickets cost $285.30. that has to be the same as how many tickets over 808.35. Okay, so when I cross multiply, the product of the means, 285.30 times x, has to equal 6 times 808.35. 6 times 808.35. Whoops. 6 times 808.35. What is going on? 6 times, thank you, 808.35 is equal to, so I've got 285.30x has to equal 4850.10. Now, in order to get x alone, I'm going to divide this by 285.30 to get 17. So I can see that x has to be 17 tickets. Okay. Let's look at the second problem. Vincent purchased an N-scale model for a railroad car that is 4.7 inches long. N-scale is 1 to 160. What would the dimensions of the railroad car be in inches and feet? So now I need to get to the real one. He purchased a scale model that is 475 inches long. So we're going to compare the scale model to the real thing. Okay. Scale model is 4.75 inches. The real thing we do not know, that's our x. N scale is 1 to 160. So when I cross multiply, I have x times 1, or x, is 4.75 times 160, which is 760. And this is going to be in inches. They want this in inches and feet. So 760 inches times, in 1 foot, there are 12 inches. That's my conversion. So I'm going to take 760 and divide it by 12. And I get 63.33 feet. Now, since there are 12 inches in a foot, I know there are a whole 63 feet. And then I need to take that 0.33 and multiply it by the 12 inches in a foot. So 63 feet, 4 inches. The dimensions of the railroad car, the length of the railroad car would be 63 feet, 4 inches. That's a long railroad car. That's okay. 21 yards, that's all right. Okay. All right, recipe conversion. We've got some porcupine meatballs. I love porcupine meatballs. My gram used to make porcupine meatballs. If you don't know what they are, they're fantastic. It's basically like a meatball that also has rice in it. And they've got this sort of green pepper booyah ragu type flavor to it. They're great. All right. The restaurant would like to serve this recipe for porcupines, but they need to be able to make 100 jumbo meatball servings at a time. Of course they do. It's a restaurant. Use the proportions to adjust the amounts of beef, rice, onion, and chicken broth. So I'm not having you do all of it. We just want to do these 4: beef, rice, onion, and chicken broth. Okay. I did include a link to the full recipe if anyone is interested. So, beef. For the beef, 2 pounds make 6 servings. Then this is the same as how many pounds for 100 servings. So, in order to complete this, I'm going to cross multiply. So, 6x would be 2 times 100 or 200. So x would be 200 divided by 6. Or 33.33 pounds. That's how much beef we need. For the rice, where's the rice? Oh, 1 cup makes 6 pounds. Then x would make 100. And we'd have 6x would be 100 cups. So 100, divide that by 6. And x would be 16.67 cups, or 16 2/3. What's the next one? Onion. What do we have for the onion? 1/4 cup of minced onion. So 1/4 cup feeds 6 people. Then x would feed 100. It's not 6 people, it's 6 meatballs. So when I cross multiply, I'm going to get 6x is 1/4 of 100, which is 25. Dividing both sides by 6. See, I can do 1/4 times 100. It's going to be 25. Divide that by 6. And we get that x is 4.17 cups of onions. Right? Because that was a quarter cup minced yellow onion. Yep. So we need just over 4 cups of onions. The last one is chicken broth. So if I'm going to convert the broth, where's the broth? That's water, salt, teaspoon, tomato sauce, 1/4 cup low sodium chicken broth. Is that 1/4 or is that 3/4? Hold on, Amy. Look close. I don't know if you can see. I can't tell. I'm going to get up close. Because I can't tell if that's 1/4 or 3/4. Oh, that's a 3. That's a 3/4 cup of broth. Okay. I thought, why would I do the same? I didn't think I would do the same as the last problem. Okay, so for this one, we'd need 3/4 gives us 6 jumbo meatballs. And how many would give us 100? So I'll do the 3/4 times 100. So 6x would be 75. So when I divide that by 6, we get 12.5 cups. All right. So I didn't have you do all 4 because they're all pretty much the same process. But I did want you to see that you do get quite different numbers based on what you started with. So, yeah, it's pretty nice. Now I've got a recipe I need to make too. All right. Let's take a look at the last bit. The last bit is going to use similar triangles. So we're going to use proportions to solve problems that involve similar triangles. Similar triangles are triangles with the same shape, same exact shape, and angle measures. But different size. So when you have 2 similar triangles, it's basically the same triangle that is then shrunk down to a slightly different scale. It's either been shrunk or it's been dilated. Dilated means it gets bigger. So it's either been shrunk down or it's been dilated. Other than that, the triangles are exactly similar. The angles are all the same. The angles match up. But the sides do not. The sides are proportional. Right? Now, the only other thing I need us all to agree on, or to explain so that we all agree on it, has to do with 2 things. First of all, we're making the assumption that anything coming up out of the ground, anything growing out of the ground, anything built out of the ground comes out at a right angle. We talked about this with the Pythagorean theorem a little bit earlier, right? At the end of the last chapter. We need to assume a right angle with anything that meets the ground, grows out of it, is built against it, okay? So where appropriate, assume a right angle. The second thing we need to talk about is the idea of shadow. Now, I had this discussion a long time ago with different people. They saw they saw it a whole different way than I did. So I want to make sure that we are clear, you and I. And that is that where is your shadow? If you have a tree and they talk about where that tree's shadow is, the shadow will always be along the ground. The shadow is on the ground. Yes, all of this is in shadow. But when we talk about the length of the shadow, we're talking about that shadow along the ground. Okay? We're all going to be on the same page with this. The shadow is not diagonal. The shadow is flat on the ground. That's where the shadow is. Height goes straight up and down. Shadow falls along the ground. Right? This is going to come into play in the very next problem. So here we have a 12-foot light pole. Here's our light pole. It's going to cast a shadow that is 15 feet long. So when we say 15 feet long, we're going to assume that this shadow is on the ground and it's 15 feet long. At the same time, there is a man somewhere in here, and he is going to cast, here's our man, he is going to cast a 3-foot shadow. We want to know the height of the man in inches and feet. So, do you see the two triangles? Can you see the triangle here and the triangle here? These two triangles are intended to be similar. So we will set up a proportion that states 12 goes with 15. We're comparing the height, by the way, to the shadow. 12 goes with 15 in the same way that this unknown height goes with the 3-foot shadow. All right? In order to solve this, the product of the means must equal the product of the extremes, or 15x has to be 36. When I divide that out, 36 divided by 15, or 2.4. This is 2 feet, and then 0.4, it's 2 whole feet. 0.4 is left, which I need to multiply by 12 because there are 12 inches in a foot, 4.8 inches. So this is 2 feet, 4.8 inches. I don't know if this man is just particularly short or maybe it's a man-child, but this is 2 feet, 4.8 inches. Doesn't make a whole lot of sense, but all right. Let's try number 13. This is one of my favorites. The St. Louis Arch is 630 feet tall. During a recent visit, my sister took a photo where the arch appeared to be resting on my niece's head. Callie's 16. She likes to take Instagram-worthy photos. She's 15? Yeah. No, 16. She's got a driver's license. All right. Assuming that my niece is 5 feet tall and that she stood 110 feet from the base of the arch, and that the camera was placed on the ground in order to take the appropriate photo, how far was the camera from my niece's feet? So I'm going to draw sort of a pour diagram here. So here's my St. Louis Arch. If you've been there, you know. Right? And we know this arch is 630 feet tall. So the height of this arch is 630 feet. 630 feet. Okay. My niece stands 110 feet from the base of the arch. And Callie, we'll put her in a skirt because she's rather girly with long hair. Callie is 5 feet tall. She stands 110 feet from the base of the arch, and the camera was placed on the ground here to take a photo. Now, in the camera shot, it looks like the top of the arch is resting on my niece's head. So it's a perspective photo. She's standing way, can you see it? She's standing way in front of the arch. Question is, how far is my niece from the camera's feet? Or how far from my niece's feet is the camera? Okay. This is known as an embedded triangle because there are two triangles here, but one triangle is inside the other. If this is 630 feet, then the distance, the entire length of this side is 110 plus x. If my niece is 5 feet tall, then the camera stands x feet in front of her. I can compare the height of the objects to the distance to the camera. Distance to camera. And I will have 630 over 110 plus x has to equal 5 over x. I can still use the means extremes product theorem, meaning I can cross multiply. 5 times 110 plus x has to equal the product of the extremes, 630 times x. So 550 plus 5x has to equal wow. I feel like something's wrong. Nope, we're right. 630x. So I'm going to subtract 5x from both sides. 550 is equal 625x. So I subtract 5x. See why I don't like this. And so now I need to divide both sides by 625. So 550 divided by 625. That's not right. 550 divided by 625. There we go. 0.88 has to be the x. 630 goes with 110 plus x, the same way that 5 goes with x, and x is 0.88. That was not the answer I was expecting. But does it work? I think it does work. $10.88 times 5, and I get 554.40. 630 times 0.88, and I get 554.40. Okay, it works. So 0.88 feet, which, in order to figure that out, I'm going to take 0.88 and multiply it by 12, and I get 10.56 inches. So it was under a foot. She was essentially standing on top of it in order to get it to work. All right, there we go. I have the answer in both formats, either as 0.88 feet or 10.56 inches. Beautiful. All right. If you have any questions or concerns, please don't hesitate to reach out. I'm available by email, or you can text my Google Voice. You can also reach out to the Math Center. I know that they are open. If you get stuck, just keep in mind they are open Sunday evenings from 4 to 8 p.m. this term. I'm not sure about subsequent terms, but you can always check on your My Western or on your Blackboard page. There should be a Math Center class there, classes you are enrolled in. You should see Math Center, and they post their schedule regularly, and you can find it there. All right. Thanks again, and enjoy the rest of your day. We'll see you again next time. If you need any, I know what I was going to mention. If you need any help preparing for the Chapter 7 test, I do have both the quiz and the review coming up before the test. So you've got a lot of practice just on Chapter 7, because there was a lot in this chapter. But if you need more, let me know. I've got some other ideas too. Okay? Thanks. Have a good night. Bye-bye.